off, and on the other end, you just base64 decode it, you get an AMR file, and you can play yourself the audio. We do that by creating the player using the capture://audio function to manager.createPlayer, and then we set up a record control and an object to hold the recorded data, and then just start the recording. Close it, commit it, finalize it, and send it off the device. So now we're going to move into listeners a little bit. The location listener is a really cool one. We create a listener that implements the particular interface so to do the listeners, it's slightly different. You create a class that implements the interface that we're interested in. So for location listener, we create a class that implements the location listener interface. And then we get an instance of the location provider class and the location listener with the first parameter of our custom class. So what that does is it actually uses our class and calls the events through our class prior to passing the events through to the normal location. So in this particular case, every time an event update is the one I trap. Every time a GPS update event is fired, our class is called and our particular method is called so that we can then trap that in real time. And you'll see the LL there is a new instance of the local listener, and then the LP. And the ones, I forget what they all stand for, but one of them is every second it's going to fire a location event and pass it off to my code. So here we have the SMS outbound listener. Creates a class that implements, again, the send listener interface. We add the send listener. And then once the send listener is added, every time that the specific events that we're interested in this case, the outbound SMS occurs, we can trap that and send it to the exfiltration method. The PIM listener is just like the other listeners. Again, this time we trap item added, item removed, and item updated methods by implementing the PIM listener interface in a custom class. And we trap all of those and exfiltrate the updated, added, or deleted data so that you can see that in real time. So now we move into exfiltrators quick. And I know I'm hauling here because I have a 13-minute demo video, and I want to make sure that we can at least see this stuff in action at the end. So exfiltration-wise, we have a number of different methods. This one is the SMS datagram method, which, by the way, if you have a lot of context, you don't want to use this. I learned that the hard way when I sent 600 SMS messages off my phone because I dumped my entire contact database by mistake. But I'm sure my employer's happy to find that bill. So the first step in SMS datagram is to open a connector to the SMS, and you see here the pnum and then port. This.pnum is configurable from the command and control, so you can set it to whatever pnum you want. I could have made the port configurable as well. I chose not to. And then we create a new datagram and convert the message that we got in from the listener or from the individual dumper, convert the message we wish to send into a byte buffer, and we send the data into the datagram, pack the datagram, and jam it out the wire with the send method. We also have HTTP GET POST. This is a second example of an exfiltrator that was built into the code. The GET model uses the connector method that we saw before. It uses a string of HTTP ://URL/message. The URL itself is, again, configurable, so we can say we want to pass the data to a domain that we own, and then we append the message as a /message at the end of that GET request. And all we have to do is look at the logs, capture the data, parse it out, and drop it back into whatever we want. Post method is similar. That's on the bottom half here. I actually exfiltrate it in two spots in this example. You'll see the second line, I'm actually setting the data to be the user agent. So just as a secondary example of how you could do it. They could do the same thing in the gets, but I did it in the post there. And then down at the bottom, you see the OS write, where I'm jamming the message bytes into the output stream and sending it out the HTTP post data. So conceptually similar, but slightly different programmatically. All of the listeners are threaded-based exfiltration, so I spawn a thread for those. By this, I mean whenever a listener exfiltration is attempted, we spawn a new thread. So the operating system and event queues don't bog down, waiting for responses. Again, that 600 SMS message thing I did by mistake told me I had to thread those listeners because it just bogged the crap out of my BlackBerry when I was doing debugging. But it allows us to queue the messages outbound if the network is slow. So to do the threaded exfiltration, I extended the thread class and created a custom threaded send class, I called it. and then use the run method within the threaded send class to call the exfiltration function, which actually sends the data outbound. So I just wrapped it in a thread, essentially. So there's the commands. Command and control is locked to inbound SMS, as I mentioned. We initialize a listener at application startup to listen for any inbound SMS messages, and if you've set when you compile it, if you set it to be a system module and a auto-run module, it'll happen after reboot automatically, so you don't have to worry about getting the user to actually rerun it each time, which, by the way, is blocked in 5.0. So you can't set it as, I believe you can't set it as a system module in 5.0, but whatever the case may be, 5.0 has limited some of that functionality. So essentially the way the command control works is if the inbound message doesn't match any of our commands, we pass the message through to the inbox, the SMS inbox cleanly. If it does match our commands, we execute our individual command in a big case statement. I mentioned I did not drop the code. I did not drop the inbound commands. I left them noisy intentionally, but it should be easy for you guys to figure out how to either move it to like email or move it to TCP or something to that effect. So those are the commands. They all stand for something like PH-LON is everything. TXS is my initials, first of all. I should probably tell you that. PH would stand for phone listener on. PHL off would be phone listener off. PIM on is the information manager on and off, the listener for it. SLIN on is the SMS listener inbound on. So the rest are pretty logical. The commands make sense and should be pretty straightforward. The no authentication on this code. So if you infect a phone and somebody else figures out that it's infected, they'll be able to do the same things you will. So keep that in mind if you start playing with the code. Methods of detection and future work. This is kind of the point of this talk is where do we go from here? So I've created this proof of concept code so people can understand that this stuff is possible and is already being done in many, many places. But where do we go from here? How do we make this better across the board? First of all, additional operating system prompts would be great. I know there'll be backlash. I know RIM would not necessarily think that's the best thing in the world to do, but remove the trusted application prompt and just make everything prompt by default so that when you run an application for the first time, it prompts up a box and says, this application is attempting to access your contact database. Do you want it to? And then it's on the end user. Now, you guys can do that yourselves, but it would be kind of neat if RIM put it that way for across the board. Generally, we're still using signature-based, and that solution is just not going to work. That's how the current antivirus world is failing, so we don't want to worry about signature-based. Sandbox-based execution still requires you to execute it in a sandbox, and you can't ever ensure that the execution executes everything within the binary. So you can't be entirely sure that you've executed full functionality of the application. So that's not going to work well as a detection method either. The most effective detection method would be static decompilation and analysis, which is difficult from an automated perspective. But conceptually, the idea is we decompile the application, which should be straightforward given that it's Java wrapped with their proprietary code format. So if we can reverse engineer the code format, get the Java JADed out, we should be able to manually inspect what each application does. But enumerate the sources of sensitive data. Whenever one of the applications that you've downloaded is touching data on your phone, get a list of that. Then we enumerate all of the exfiltration sinks. We look at all the ways that a binary can send data outbound. So if the binary is calling an HTTP outbound socket, we enumerate those for that particular binary we're looking at. And then we map the control and data flow for tracing and sensitive taint tracking between source and sink that we've just defined. And if we compare those findings, we say, okay, this binary looks at contacts, and we trace it through, and it sends that data out via SMS. Okay, it potentially could send that data out via SMS. We need to know, okay, is that an accepted source of data exfiltration for this style of application? Is that something that the application is intended to do? And raise red flags when that is not the case, and question why that's the case. So again, you really need to target the binary here. So future work, reverse engineer the code file format, as I mentioned. It's funny enough, I was researching online, looking if anybody had done this, and if anybody else knows about anybody who's done this, let me know. There was one guy who was spending some time reverse engineering the code file format, and he was on some forums, and he was posting some examples, and he got to the end of the food chain. He's like, I think I got it, and then poof, he disappeared. never to be heard from again. So figure that one out. Continued research into unobstructed installation methods. That would probably require exploitation and would probably be patched and fixed fairly quickly by RIM. But it's obviously some additional great future work, offensive future work that should be done to help harden the device. Maybe infect some PCs with a virus that acts as a distribution hub so that we can get the worm onto the PC, so whenever they plug in their BlackBerry, it jams the spyware onto the device. So that's a potential infection route. And last but not least, we need to research some additional exfiltration methods for tunneling, which I already have in the works for the 2.0 release for non-prompting exfiltration. So let's take a quick look at the demonstration. My little pulp monkey here is showing us.
Hi everyone, this is Chris Eng from Veracode Research. Today we'll be demonstrating.
Oh, nice.
BB's
QuickTime crash. All right, I just got owned. Hold on. There we go. Drag it over to you guys. Hold on. That was the play. There we go.
Hi everyone, this is Chris Eng from Veracode Research. Today we'll be demonstrating TXS BB Spy, a proof of concept BlackBerry spyware.
So that's my boss, and we can all make fun of him later for narrating this video.
TXS BB Spy was developed.
I'm periodically
going to
mute the video so I
it
can
is
talk
to
over him
create
and fast forward and
malicious
stuff because we don't want to be
applications
bored too much
using
by
the
his
handset
yapping.
provider's own APIs.
Like right now.
Most consumers aren't aware of the range text messages starting with TXS
So what we have here is the
EXFIL email.
Hush. What we have here is the a Google Voice system, and you'll see that we send it a TXS EXFIL email command. So this is actually targeting a real phone. The phone number you see up there is this phone right here, and we can actually show the demo if you guys want to play with it afterward. We send it the exfil email command, which tells the phone to exfiltrate the data via email. And I think that's the TXS EM command, which is telling it to which target email to exfiltrate the data to. Those go inbound over SMS. I can't see that. He's yapping about something now. What's that one say? DumpCon? Is that the DumpCon? Yep, so that command TXS DumpCon actually dumps the contacts off the phone. And what he's going to do now is he's going to switch back
to our Gmail account
his,
and wait for the data
the
to
Gmail
arrive.
account that you saw there in the list, and you'll see the contacts come flooding in. He had to refresh a few times. And we see some addresses here. See some phone numbers.
As you can see, we are receiving some emails containing address book entries for Barack Obama, Homer Simpson, and a few other contacts.
Double size the video? Oh.
Let's dump his email now by sending the command TXS
I don't know how.
dump email.
I can't see it. This one? Where?
Again, the spyware will send one email for
one?
each message in his inbox. We'll switch
Where is
back
it?
to Gmail to watch the data come in.
Right there? Thank you. Oh, good job, Control F. Yeah, you guys are awesome. I'm glad I have all my friends in the room. Control F. Come on. Nice. Now you guys really screwed up my demo. Yes, Windows is awesome. What the hell did Control F do? Jesus. There we go.